Alrighty, statistics. Statistics again is going to be looking at this. We saw this in we watched our probability video, but statistics gives us the information of what's in your hand and basically says what's in the pail. So what is statistics? Statistics is the science of collecting and describing and interpreting data. There are two areas of statistics. There is descriptive statistics and inferential statistics. Descriptive is collecting and presenting and describing a sample of data. Inferential is making decisions based off of that data population. So example, the state average ACT score is a 20.4 in 2019. There was 16,951 total Utah graduates. That's a 93% indicated of having interest in a STEM major or career. Now, those who aspired into a STEM field average was a 20.4. 17% of those the 2019 Utah graduates met the ACT STEM college readiness benchmark, which means that they had a science and math score greater than 26. So in 2019, Utah graduates meeting the ACT STEM college readiness benchmark had an average science score of 28.5. In 2019, again, Utah graduates met the ACT STEM reading benchmark had an average the readiness had an average math score of 28.4. So we can look at all those numbers, and they were throwing a lot of numbers out, but on that meant that we can look at that and we can see this data, an actual legitimate, got this from the ACT website, and it's telling you statistically about you, the students, about what your ACT math and science scores should be to be successful, because the ACT STEM score says that if you get a 26 and associated with it, you will get at least a 50% chance of earning a B or higher in your science and engineering and math and technology related courses of study. It's kind of an interesting thing. You can actually look at the website and you can actually click here where it says click here, click on the here, and it will actually take you to that website. You can actually look through that and then compare that to your either ACT scores or your future ACT scores and see, hey, if I get this point, I can actually be successful in college as an engineer. That's kind of a useful statistical looking at statistics and being useful for that. So let's talk about the introduction to the basic terms. There's the population. The population is a collection or a set of individuals or events that you're looking at to be analyzed. Now, a sample is a subpopulation, so we're looking at a group of that population. Now, there's a variability. Variable is the characteristics about the individual that you're looking at. So what are you looking at? Are you looking at their, are their ages or their ACT scores? The data is the singular data is that value of that particular associated with that one variable or population, that value. It could also be plural or sets of data values belonging to multiple sets of data belonging to those people. Then there's the experiment, which is the planned activities whose results yields a set of data, and the parameters, looking at what is the numerical value summarizing all the data of an entire population. And then there's the statistics, the numerical value summarizing the data set. So let's look at an example of this. The school board is interested in learning about the average age of school staff. Identify the basic terms in this situation. Well, the population is the age of all staff members at the school. A sample is we can look at a subpopulation. For example, we might be able to select 10 staff members at random and determine their age from the school. The variability is age. The data would be the actual data of that specific staff member. The data would be then the set values of those. Now, the experiment would be the method used to selecting the age and forming the samples. So are we pulling one person, 10 teachers from one school, or are we scattering it from Bear River and elementaries and the middle schools and our high school and everybody? The parameters are those we're interested in the average age of the staff, and the statistics is the actual average age of the sample. Now, there are two kinds of variables. There is qualitative and there is quantitative. Qualitative which deals with an attribute or categorical or variables. They're going to be variables that that do not have arithmetic or mathematical things to it. They have no such thing as adding or averaging. It's usually about the quality of the variable. Quantitative, meaning it has some quantity. It has an arithmetic operation, such as you can average it, add it. It has data that's a little bit more meaningful to us. So we can look at these and we can actually see each of the following examples as attributed to qualitative versus qualitative or versus quantitative. So a city students live the cities that students live that take place in AP Calculus. That's an attribute, qualitative. The amount of gasoline pumped by the next 10 customers at a local Wally World, that's numerical because you can actually count how many gallons. The amount of radon in a basement for each of the 25 homes in a new development. Again, we can numerically calculate that. The color of baseball caps worn by each of the 20 students. Well, again, I can that is color, and that would be that'd be an attribute or qualitative. The length of time to complete a homework assignment, again, that's numerical. The state in which each truck is registered when stopped and inspected at a weigh station, and again, that's attribute. So we can look at variables, and we can look at qualitative and versus quantitative. Now, qualitative can be broken into nominal and ordinal, and quantitative can be discrete or continuous. So what does nominal mean? Nominal variables are things that cannot be categorized. But ordinal has some ranking to it, can be organized in a ranking, like first, second, third. Discrete variables are where they can assume a countable number of values. It has discrete values. It can be assumed that the value is corresponding to an isolated population, a line of intervals. That is, there is a gap between any two values. A continuous is the assumed that has an uncountable number of values and is continuously can be assumed that any value along any interval can include every possible combination. So let's look at that. And in many cases, a discrete and continuous variables may be distinguished by determining whether the variables are related to counting or measured. If you can count it, it's discrete. So how many green Skittles are there in a bag? That is the discrete. You can count it. You can't have a half of one. If you do, that's that's weird. There is gaps. There's you can have 15 or you can have 16. On the other hand, continuous can be like measure the diameter of this sprocket. That one you can have depending on the sensitivity of your measuring device. This measuring device is measuring out to the hundredths of a millimeter, but he can get one that can measure out to the thousandths of a millimeter, or the millionths of a millimeter, or the micrometers. He can pull out a micrometer and measure down, and those values change based on the measuring device itself. So we can let's look at those: nominal, ordinal, discrete, and continuous. So pause it and think through these. So length of time until the pain reliever. The number of chocolate chips in a cookie. The number of colors used in a textbook. The brand of refrigerator at home. The overall satisfaction rating of a new car. The number of files on a computer hard drive. The pH level of water in a swimming pool. And the number of staples in a stapler. So the length of time until a pain reliever, that's going to be continuous. Depends on how accurate your pain reliever, what you're measuring it with. The number of chocolate chips, that is going to be discrete. The number of colors used in a textbook, discrete. The brand of refrigerators, that's nominal. The overall satisfaction, that is ordinal. The number of files is going to be discrete. The pH levels continuous. And the number of staples is going to be also discrete. No matter what the response variable, there will always be variability in your data. One of the primary objectives of statistics is measuring that variability. How is that? And then controlling it or reducing that variability in the manufacturing process using statistical process control and controlling how much. So for example, a supplier fills cans of soda marked at 12 ounces. Well, how much does each soda actually have? Well, it's very unlikely any one can contains exactly 12.00 ounces of soda, but some cans can have a little bit more, and some can have a little bit more, some can have a little less, but on average, they all contain 12 ounces. And the process is try to control that so it's so close that basically nobody's going to complain that their 12-ounce can is a little shy or a little over. So the way you do that is by data collecting. The first problem of an engineer is how to obtain the data. It's important to obtain good data and representative data, and then you can make that inferences based on those data. So you're wanting to make sure you remove as much bias sampling as possible. So bias sampling is a sampling method that produces data which has systematically differs from the actual population. Unbiased sampling is one where it's not biased. So you can sample it by bias sampling can actually come by convenience. You just like sample one thing because it's easier to do that way. I go to my class and say, all right, how many boys and girls are in this class? Oh, there's only 2 girls in this class. That must mean that the population is like 80% boys. That's not really good. It's convenient that I asked that my class, but it's not really true representative. Or I can ask, all right, how many of you want to help me after school? Oh, nobody? Well, I guess everybody here at the school is a jerk. No, because nobody's going to volunteer, because either if you do volunteer, it's because you're either getting paid, but people who don't need the money aren't going to volunteer. The experiment is the investigation and controls the modified. The environment observes the effects of the variable. A survey is the data that are obtained by sampling some of the population, and a census is 100% of the survey. So the survey is only looking at a small section. The experiment is actually looking at the experiment itself, and the census is 100% survey, and is very, very difficult to do. Sampling frame. A list of the elements belonging to the population from which a sample will be drawn. It is important to note that the sampling frame will be representative of the population. So when you look at a population, you have to be selecting that sample from that sample frame. There are many different types of sample designs out there. Usually they're all fit into 2 categories, judgment or probability. Judgment sample is based on a typical. The item is selected that are representative of the population, and the validity of the results is a judgment. It sounds good from the collector's perspective, and then there's the probability sample, and this is where you're looking at more on a numerical level. Now there is random sampling, which you look at the sampling as a whole and you randomly do it. Looking at it, like for instance, you can take a randomizer, and randomly calculate something and come out with it. There is inherent in the concept of randomness that the next result is not predictable. And the proper procedure for selecting random sample, you can use random number generators or a table of random numbers. So for example, a civil engineer needs to sample concrete from a cement truck that are being used to make a new highway. The cumulative volume of poured concrete is tracked. There is 2,100 cubic yards of being poured. The quality test engineer then tests 3 consecutive trucks at the beginning of the pour, and if they pass, after each failed or after every failed check. Then they have to randomly thereafter 800 cubic yards every 800 yards. Using a 5-digit random number, they sample is identified, and they sample like at 700, 840, 1,730, and so on and so forth, all the way up to the 22,100 cubic yards of that concrete. So now what we're going to do is look at the mathematical and statistics, the mean, median, mode, and standard deviation. So the mean is just the The mean is the mathematical average. It's just to take all the sum of all the parts and divide it by how many things. It is symbolized by the Greek letter chi, which is just the x with a bar. That's the traditional symbol for the mean. The median is how often something occurs. It is the numbers that is in the middle of the set of data. And the mode is often the set of data that occurs the most frequent. There you can have one mode or bimodal or no modal, and that's just how often something occurs more often. Now, what does this all mean? So those are pretty middle school level words. Well, what does it mean? Well, if I look at scores, let's say for instance, I can look here, and if it's normally a nice little bell curve like this, mean, median, mode will occur here. But sometimes the numbers can skew one way. The mode is always the top of the curve, mean is always the average, and the median is in between the mode and the mean. And so you can actually see it's skewing one way or the other. Now, the standard deviation shows the variation in that data. How much of a variation is there? If the data is close together, or is it spread out? If the data is spread out, the standard deviation will be larger. The standard deviation is denoted by the Greek sigma, and it looks like this is a kind of a chart. So very small standard deviation, a medium, and a very large standard deviation. The equation is this, but do not worry, we will not use a computer to calculate the standard deviations. So here's an example of standard deviations. If you are in the middle average person, you will make up 68.2% of the population right here. But if your standard deviation above the mean, meaning that you exist here, that means that 13.6% of the population will be in this area. So, and everybody else will not be. If you're 2 standard deviations, that means you're 2%. And if you're 3 standard deviations, that means you're 0.1, meaning 99.9% of the population is below you. Meaning if you are 7 foot tall, you are 3 standard deviations above the mean when it comes to your height. There's nobody else taller than you in literally 1,000 people. So, statistics and technology. Electronics have greatly enhanced the ability to use ability to actually do statistics. Now we can do this using computers, and calculators are really good at doing this. But remember, it's the responsibility of you, the statistical and your statistical methodology, to figure out if that number is an accurate representation of that data. You cannot just rely on a computer to do it, okay? If you have any questions, please go ahead and write them down, and we'll have a good day.